Okay, we're gonna get started, everybody, on 3D printing. Or sorry, not 3D printing. I'm tired. On laser cutting. Um, let's see. So everybody, we're gonna go to the laser cutting lab later today after this session, and just kind of take a look at how it works. But I'll give you guys a crash course on kind of the process on how to do everything. So first up, let's go to the website, right? I sent this to you guys earlier this week or last week, the Fab Lab. Basically, in order to actually laser cut, you need to make your template, which I'll show you guys how to do in RHINO. And then at the Fab Lab, they have all their cutters with AutoCAD set up on them. Essentially, what we're going to do is we're going to take our RHINO file, import it into AutoCAD on the laser cutters, and then they have instructions there that you can follow and a process that you can follow to cut your material. Now, in order to actually cut your material, you could either walk in if you wanted to, if there's an open availability, or you can go onto their website here and go down to, okay, over here, fabrication process, and it's schedule. And this pulls up the schedule for all of the open slots. Since it's near the end of the semester, they're all full. So this should be fun. So yeah, let's see. There was one open on Laser 5 earlier from 9 to 10. So that's nice. And now all of the other ones are full. Word of advice, you can probably just show up in the middle of an appointment and just kind of camp out and wait, because some people don't use that entire time slot. So they'll probably either, finish up, cut their material. Maybe it takes them 20, 30 minutes or so, and then they'll leave. So that's an option. The other option is to basically wait until 9 a.m. rolls around the next day, and then as quickly as possible book in advance, because 9 a.m. every single day, everybody tries to hop on these things and they get booked. So if we go to tomorrow, so it looks like there's a lot more open, fortunately. So you just click here and then you can click create reservation to book your appointment. Now, lasers, I think it's lasers 1 through 4 are all 24 by 36, 2 by 3 feet. Laser 5, that one's slightly smaller. They used to have the dimensions here, but I don't know what they are off the top of my head. So when you're booking, just keep that in mind, that you need to fit your material on that bed, essentially, right? So you can't have a giant piece of cardboard or whatever and expect to fit it in the laser cutter. You got to make sure that it's scaled or cut down to size, essentially. And they have this machine outside of the Fab Lab that you can use to actually cut your material as well. If you don't have a sharp enough blade, there's instructions on the wall. And all that good stuff. So that's essentially it for the whole booking process, at least. Any questions so far? Yeah. So you used to, but right here, basically, reservations can only be made 24 hours in advance. So even though they word it like that, it's weird. Essentially, once 9 a.m. rolls around, so like if I wanted to book 2 days from now, right, I would have to wake up, set my alarm, right, and immediately try to book a reservation at 9 a.m. because that's when everything opens, right? So 9 a.m. tomorrow, I'd be able to book for the next day. Like just all of them open the next day, essentially. But, 9 times out of 10, they'll get filled up like this, at least especially like this late in the semester. And I mean, you guys will have to work around stuff like that. So like for me, at least for studio, I managed to get most of my laser cutting done a couple weeks ago, since, it's not exactly my first rodeo. So, try to get as much crap as I could done prior to everybody else trying to come in and laser cut. So now I'll show you guys the process as far as the cut though. But essentially you guys can get like really cool models looking like this. So using kind of a combination of like the stuff that we've been showing you. So this is all laser cut. The buildings are actually 3D printed. And then, foliage and stuff you can just get from like Hobby Town or whatever, Hobby Lobby, stuff like that. So here's like some image. So those are the buildings. My colleague and I just picked them up last night, so that was really fun. So still working on 3D printing since, you know, all of those are filled. So thanks a lot, everybody. Really appreciate it. You know, I mean, we're all in the same boat essentially. But yeah, so you know, you guys will be able to do stuff like this eventually, which will be super, super sick. So, but just kind of, you know, obviously for this class, you know, we have to laser cut within like the next like week or so essentially. So, you know, hopefully Oakland will be lenient on that. I'm sure the rest of the department will be as well. You know, this whole model making experience isn't exactly for you guys to get these buildings right on the first try. It's more just the process, more or less. So literally, I mean, I saw all y'all's 3D printed buildings so far when I came in, and they look loads better than my project. I didn't even make a physical project for my DCOM 1 model, so if it makes y'all feel any better. So, you know, then again, COVID and all that too, but, you know, change stuff up. So here's a quick example, essentially, of what a laser cutting template should look like. So in RHINO, what you're probably going to want to do is make 2 layers or 3. So we have this layer called laser cut, all caps, this other layer called laser score, all caps. Laser cut is represented in red and laser score is represented in yellow. The reason why is they have it set up at the Fab Lab where essentially it recognizes the different colors. So the laser recognizes it, it goes, oh, this is a red color, we're going to cut all the way through it, and then everything that's yellow will just score essentially. So if you prep up these layers like this, it'll make it easier when they're imported into AutoCAD. That way you guys don't have to worry too much about learning, you know, another program. All you'd have to do is just import it and then just use the move command and move it over to their template that they have that I'll show you guys later. But doing this will essentially make the process a lot easier for you guys. That way you don't have to move things or change colors when you're in AutoCAD. So make sure you have those 2 layers. Sometimes I like to make a third one. I just call it template and I'll lock it sometimes. And, you know, like I said, the bed size is typically a 24 by 36. So what I'll do is I'll just make a quick template inside of RHINO, make it 24 by 36, scale down all of my things I want to cut, and then make sure that it can fit on each essential layer. So like this topography over here from this model, right, you can see that there's multiple layers to this thing. So essentially back in RHINO, I had this massive topography here, and then I split that up into different contours, into different layers. So like so. So we have layer 1, 2, 3, and so on, and then you just glue them together essentially. This was actually at 1:1 scale, and then I just, you know, scaled down in RHINO, scaled command, and here it is, fit it on a 24 by 36 now. So this template right here is a 2 by 3, but this is the exact size of just, you know, the site that I was cutting, because that's just the context I wanted to fit at that scale. So it's not like you have to use the full bed. As long as everything just fits on it, you're fine. So, and then once I did that, then I basically just split each of these up into as many sheets as or as little sheets as possible. So I had essentially all of these layers, and then I basically fit them on like puzzle pieces onto each of these templates. So in essence, all of this material, or all of these layers were only able to, or only had to fit on these 4 pieces of cardboard essentially. So just kind of think smarter when you're doing stuff like that. You know, you just kind of want to save material. So I had multiple layers on one sheet. So that ended up working out pretty well. Now for you guys, right, we're not really worried about a topography. We're doing like the interior walls for the building. So how do we do that? So I'm going to go over to my studio project, and we'll take a look at these buildings right here in 3D view. So we have these buildings. I don't think these ones have interior walls, but I'll just show you the overall process. Essentially, interior, exterior, it's all the same. So let's take one of these real quick. And then what we'll do is we'll ungroup this. So there's multiple ways that you can do this, but essentially the way the laser cutter works is it cuts out the material on a flat surface, right? So you don't want to cut your walls from a top-down view because that's not going to do anything, right? Now you can cut your ceilings from a top-down view, right? So if we had this and, you know, made that into lines, then we could essentially cut that, right? Just get the line work for it, and the lasers would cut around it, and then that would be the material itself, right? Now for these, you know, for these vertical walls, looking at it from a top-down view, you don't want to cut it like this because you just, you know, you're not going to get your wall. You're not going to be able to prop it up and glue it to the side of, you know, of your model. So essentially what you would want to do is you would want to move this and then just use the gumball tool and then rotate it essentially. I don't know why the gumball tool is giving me this. Let me do this real quick. There we go. So, you know, just use the gumball tool, right? Rotate it 90 degrees. There you go. Now you have your surface with, like, this one has all these windows, right? And now it's flat on the bed essentially. So, and then the laser cutter can recognize it. It's literally a laser and it just traces around. So, so that's essentially what you would want to do. So I'd recommend doing that first in your models and stuff. So get all of these walls oriented in, like, you know, like this, where they're just top facing down. So you guys only need to do interior walls, which is good. So just pull all of those out. So essentially, you know, we can start pulling these walls out as well. These ones needed to be rotated this way. Same here, right? So that's the general idea. So like so, right? And then if you have like multiple floors, you know, you could just do the same thing. So, and then maybe you want to think like, you know, just work smarter, not harder. It's like, okay, I have like 5 of these floors right here and they're all the same plate. They're not different dimensions. We could just copy this over and over again instead of dragging them out. Visually, it might be easier for you guys to just slowly drag out the components. That way you know which ones you already have moved out of the way and are oriented right, and then which ones you know you still need to do. So I'm basically just slowly moving these components over to this side and essentially just subtracting from our overall model. So it's like, okay, we have all these components, and then these are all the ones that I need to orient left. So most of you guys shouldn't have that many interior walls anyway. Which is good, so it'll save you all some time, so that'll be nice. So we're just going to take a look at these now first. So so for these surfaces, essentially we need to turn these into vector lines, because that's how the laser cutter recognizes it because of our layers. So essentially you can do a combination of 2 things. You could either probably do project and just project this to the C-plane, so it'll all, right, project to C-plane, so it's all, oh, I didn't click yes, my bad. Project to C-plane, yeah, that's fine. And then see, it's all flat now. We can move that one out of the way, there we go. So you can do that, or another thing you can do that we learned from previous exercises is make 2D, right? So since we have all of these surfaces like so, we can literally just, you know, make 2D, make sure that, you know, your view is the active view we're on top view, and that, you know, you don't want hidden lines to be on, you just want the outlines. Click OK, and then it always goes to the origin in the world, but my model's kind of broken, so it's somewhere. Let's see. Yeah, origin is what, 18,000? No, 185,000 inches away. I forgot how to set it, so you guys shouldn't have that issue though, hopefully. Anyway, so we have these now, right? So those are all of our lines. So now what we can do is literally just highlight them, go to our layers for our properties, and just change the layer to laser cut, because we want those to be cut, right? Make sure display color is also set to by layer, and make sure print color is also set to by layer as well. Sometimes these can change depending on like graphics and stuff that you're making. So just keep this in mind. So I highlighted all of these, made sure that's like that. So all of these are red now. So, which is good, which is what we want. Now, essentially what we're saying is we're telling the laser cutter that we want this cut out, and then we want each of these windows to be cut out as well, which means each of these windows are going to be hollow. Now, you can do that in some models, but based off of my pictures, right, from this 3D print, right, these windows are insanely tiny, right? The laser cutter will probably handle it, but I mean, if it doesn't cut all the way through, sometimes it won't because the power speed isn't the best, honestly. So you'd have to do multiple pass throughs. Um, so sometimes, like, instead of having to go through all of that work, what you could probably do is honestly just highlight your facade itself. And why not just put that on the laser score layer instead? So essentially, we're just cutting out the wall, and then we're just scoring all of that detail onto the side of the building instead of actually cutting through all those openings. Typically, though, professors will ask you for a model at a decent scale like what you guys have printed out already. So you wouldn't exactly need to do that all the time as far as scoring the detail. I guess one of the times you probably could would be like for context. So like for surrounding buildings, if professors really want you to show the facade of a building outside, then you could probably just do that, that way to save you some time. But that's the general idea. Let's see. I don't have a laser score layer in here. Laser score. So essentially we could just highlight these, right? Put them on the laser score layer. So that's essentially it when it comes to setup, though, as far as setting up these files. There's another good command that you guys could probably use. So like, you guys know those like old craft kits, like back in like like I don't know, like K through 12 or whatever, where they made like those boxes and like those paper boxes. You could like fold them up into different shapes and stuff like that. Yes, no, maybe. Okay, so I swear I'm not the only one. I swear. Sort of like unrolling like a cube or something and just making like a dice or whatever. Essentially, you could kind of do something similar in here, which is super, super cool. And you can do that for different shapes and stuff like that, irregular shapes, but we could do it for a box real quick. So say we have this box right here, right? One of the things you could potentially do, right, is if you wanted to get every single surface, right? You're not going to need to worry about getting every single surface for these solids because, the thickness of this floor plate or this roof is essentially determined by the thickness of your material, right? So the thickness for my topography that I showed you guys earlier was because I chose that specific piece of material. So same thing for your interior walls, right? So your interior walls will only be as thick as your material, unless you make multiple copies of the wall and then just stack them on top of each other in the assembly process. So we could say that these are two pieces cut out, and then you would literally just essentially glue these on top of each other now, if you wanted to get more thickness. That's a solution if you don't have material that's thick enough to your needs. So you could just, cut the same thing out over and over and over again, and then just, glue them on top of each other, like so. And some people build models like that as well. So sort of like this. So if that was like a building, not walls, but yeah, that's the idea for that. Anyway, so say you want all of the sides on a shape, right? Say you were doing like a massing model or something and just wanted to do something really quick. We can click this and we can type in Unroll Surf. And what Unroll Surf does is it unrolls it. It makes sure that every single edge, at least on a certain side, is touching each other. That way, when you cut it, it will actually, you can just fold it together essentially. So we typed in Unroll Surf, and then let's see, explode, sure, we'll explode it, and then we'll click enter. I think this one went to the C plane as well. Let me see, 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 let me see Give me a sec. I don't know why it's not showing up. Normally it does. Yeah, I'm gonna try it in just a different RHINO file. There we go. Okay. So typed in Unroll surf, see how the surface is all here? So essentially, right, what we could do is the same thing. Highlight this, lift it up a little bit. And then what we'll do is same exact thing. We'll do make 2D on view. Okay. Let's see. It's giving me issues. Make 2D. Yes. Come on. What the fuck? What the Sorry, I don't know why this is giving me issues. You guys probably get the idea though, hopefully. I could probably just open this up in a new RHINO file. One of the issues probably is, and this is something you don't want to do. I do it though. I'm a bad influence. I'm sorry, but you typically don't want to have things that are like two different scales in one RHINO file. So see how right now, like this is 1-to-1 scale essentially, right? And these are like massive buildings right now, like this. These are supposed to be buildings and all that, right? So this is all 1-to-1, but also I have like my laser cutting files in here too, all the way down here. So probably don't want to do that. So that's probably why it's giving me issues. But anyways, yeah, let's just move on from that. Essentially though, right, you could do unroll surface and do exactly the same thing here, right? So unroll the surface, make 2D, and then essentially what you would want to do instead of cutting everything is you'd want to make sure that all of the lines that are touching each other are laser score now. That way you can fold it easily. So just as an example, right, we'll make a box here. Just mirror that real quick. So let's say that that was what our outcome was once we did, you know, make 2D after unrolling a surface. Then what we would do is we would probably highlight this, trim these, and then go to our laser score layer, and then we would just draw these score lines essentially. So that's what you would want to send to the laser cutter now if you wanted to fold those up. So potentially based off of this thing that I drew right here, you could say that, like, you know, you could basically just say that it's, you know, a surface something like this. And then that. And then, you know, because it's scored, you could essentially just fold it up like so. So, and then same for the other side. So, same deal. You guys get the idea. Um, any questions so far? Nothing. Um, score these ones. Mm-hmm. You can just glue them. Yeah, you can just glue them. But essentially, right, like yeah, like if those walls intersect, just treat them as two separate walls that you just glue together. So like here, so like here's a good example right here. So these two walls are intersecting, right? Just treat them as two separate entities. Move this one out, drag it, rotate it, and then do the same thing here. Move that one out, rotate that as well. Now, what you're talking about, you could totally do, and people do that for a little bit more like organic shapes. Some things that are a little more irregular. So a couple of people in my studio actually made like this semi irregular base for like one of their models to sit on. So they made like, this is really lagging. Anyway, so you have this base like this, right? And then what you could do potentially is just unroll the surface. And then because, you know, what if you wanted to wrap this like a texture around an object like this, right? You could make just a long strip of like just a really long rectangle and then put a bunch of score lines in it. And then it would wrap around that object essentially. So if I had a physical example, I'd show you, but that's essentially what it would kind of be though. So what was it? They 3D printed the base um, of the model, and then they decided to add a little bit more detail. It was supposed to be like a retaining wall or like a foundation for these massive residential apartment complexes to sit on. So what they did is they, you know, just made a super long rectangle, got a bunch of score lines in, and then basically shaped it around that 3D print because of how I don't know. I hate that we say this the organic shape. You know, it's just a blob. I don't know. um, so that's one way to do it. But yeah, if you wanted to, you could totally have, you could totally just unroll it instead, or connect both of these together if you knew exactly where they are, and then just scored them. I personally just wouldn't recommend it though. I know that might be an issue as far as like tolerance goes when scaling down because it's like certain walls might be slightly longer than they actually are or slightly shorter. So what you can do next actually, especially because you guys are making interior walls, is you can just scale this down by like 0.95 or something. That way your interior walls will actually fit inside of the rest of your model because essentially you guys made a 3D printed shell, right? So you don't want your interior walls to be the exact same length and meet or intersect into your exterior walls, right? Because even though a lot of you guys did that in your digital model, if you start laser cutting that, it's not going to fit anymore. So if you make them slightly smaller, we'll just scale them down 0.95. And you know, you can barely see that there's a difference. There you go. And you should be fine. So, um, so that'll help for the most part. Um, let's see. So after this, right, once you guys get your files ready to print, um, or once you get everything like on the right layers at least, what you can do next is start moving them onto that template layer I was talking to you guys about. So I have these, you know, boxes right here. So I didn't put them on different layers. That's fine. It's whatever. As long as it's 24 by 36, that's kind of what you want to do. So what we'll do is we'll move these onto a template. So I'm going to go ahead. I'm just going to copy this up here. And then just as an example, let's say I have very limited material to work with, right? There's actually like rulers that are on along the edge of the bed, so you can actually see how long your material is, or you can measure it, whatever's easiest for you. But let's just say our material is 11 inches by, I don't know, 20 inches, right? Essentially what you're going to want to do is you're going to want to justify that to one of the corners of the bed. And the reason why is because you want to align your material to one side. Because if you put it in like the middle here, right, that's probably not going to be the best for the laser. So always just kind of line your material up to a corner. That way it stays nice and straight. And then what we'll do is we'll move all of our things that we want to cut onto the material. So, and that's fine. You can leave it like this, but say you want to be a little bit more conservative, you can actually just butt these up right next to each other if you wanted to, right? Because what's going to happen is the laser's going to cut through this essentially, right? So we can just go ahead and just flat out move this wall right next to each other, because if it's going to cut this line right here, you might as well have it cut two walls at the same time, you know? So we can just move all these materials and just line them up next to each other. And look at how much space we're saving now on our piece of material, especially if it's really expensive. So those same guys I was talking to you about like the whole, you know, retaining wall deal, they bought 2 sheets of really, really thick acrylic because they wanted to use that as more of a massing model. So basically, they stacked up the pieces of acrylic on top of each other, and they had this thick block, and it was supposed to represent just the glazing around the entire building. But the material is like insanely expensive for like 2 sheets that aren't even like, I forgot the exact size, but they're like 2 sheets smaller than 24 by 36. They ended up spending like $70, $80. And I'm like, yeah, I'm not going to do that. I'd probably like do 3D printing or something else a little bit cheaper, especially since sometimes the department hands out and gives out materials. So I'm like, I'm going to just use what's already here because I'd prefer not to spend more money than I need to. So so I did that while they were over here, you know, cutting and scoring those giant thick blocks of acrylic. Now, what they ended up doing is they ended up messing up a little bit and wasting material. They ended up just spreading these out like super far apart from each other, right? So don't beat yourself up about it because a lot of us do it as well still. So um, just try to keep that in mind when going to cut, though. You just want to save your material, really get the most out of it more than anything. If you don't feel comfortable with putting the walls right next to each other because you feel like maybe a piece might go flying off the bed, sometimes that'll happen. Some of the smaller pieces will just fly off. Essentially, it has a fan in it. That way, the material doesn't actually catch on fire and, you know, burn the place down. So it's got like a fan, so it keeps it from doing that. Essentially, what you could do is you could just kind of move these over a little bit at least, and that way the material around that wall would kind of keep it a little bit secure. So yeah, what's up, Aaron? So it does, yeah, depending on the material you're using. So for acrylic, right, there's a sheet when like that goes over the top. That just comes like with the acrylic itself. You can normally peel it off. You can actually laser cut it with that sheet on. That way, it won't leave any burn marks on the material. Um, like typically, other things will have burn marks as well. Um, but if you use the recommended like power settings and stuff that they have there, it's all on different sheets that are printed out, like that they have, and they'll follow it. You guys can follow it step by step. Typically, though, it won't burn as badly as you think, so it'll leave like a little bit, but not that much to the point where it's like troubling or anything. So, um, like in what is it? I guess we go back to the topo I made. You can kind of see it in certain areas a little bit. So I'm trying to see. Picture's not the worst. It's not the best, but like okay, here you go. So it's actually the image might be a little weird. I don't know why it's white like that. It's not supposed to be white, but essentially that grayish is like from it kind of burning a little bit, that grayish brownish. Um, so yeah, that happens. That's kind of one of the downsides. But for different materials, you can try to not get that. So, but most of the settings that they have are kind of set up to where you guys won't have to worry about that too much. So, like for personal projects, what I do is I've looked online for ways to get rid of that. So I like to laser cut like wood and stuff like that, and I like to make some like personal wall art, and and it leaves behind like you know a bunch of scorch marks and stuff like that. But one of the things you can do for wood specifically is you can actually just get masking tape, apply a bunch of masking tape to it, and then just rip it off so there's like a thin, almost like protective layer, and then bring it into the laser cutter to cut, and that'll save that essentially. Another thing you could do because it's wood is you can just wash it off. So just water or alcohol, whatever's easiest, honestly. So um, it starts smudging at first, but you know, I mean, it's just wood, right? I mean, you see wood on like exterior decking and paneling and stuff like that all the time. So it's the same deal. But those are a couple tricks at least. So, but like I said, kind of depending on the material. So Let's see, what's the next step? So the next portion, right after you have your file already, if they're all in the positions we want them to be in, right? Because we like to save material and not be like my dumb friends, right? That'd be great. What we're gonna do next is we're gonna highlight this, and then we're gonna export it, right? So remember how we exported for 3D printing as an STL? We're gonna export this as a file called a DWG. A DWG file is something that AutoCAD recognizes, and that's what the laser cutters use. So essentially, all you have to do is export this as a DWG, drag it into AutoCAD on the laser cutters that they got over there with the computers and the software plugged in, and then follow all the steps they got there. And that's kind of the gist of that portion. So there's a lot more instructions over at the Fab Lab. But as far as RHINO and stuff you can do to prep your file, that's the gist of it for the most part. So instead of STL, because that's what we were working on last time, DWG right here, see AutoCAD drawing, save it to whatever you want. I guess we'll call it laser cut practice or whatever, I don't know. And we'll click enter, we'll click OK, and then it'll save. So I think I saved it to the desktop. Yep, there it is. So, and then I got AutoCAD here. We can literally just bring that in. We'll open it up with AutoCAD. And they have a specific file there, right? It's like a template. So you have to put your file inside of the template that they have, essentially. So let's see. Our model is somewhere. So let's see. I basically just zoom out until I can find it. There it is. And then, so I'll give you guys a couple of things in AutoCAD, just to show you guys a little bit. It's similar to RHINO in that it's command based. You can type everything, right? So in RHINO, there's the move command. In AutoCAD, there's the move command. You can scale in here and rotate in here. You can do something similar in RHINO, right? So it's a little bit similar. So we can highlight this. We want to zoom into it. So over here on the right hand side, you have zoom extents. So just zoomed in on the model. And now we have our template. So, I'm just going to draw a box. We're going to make that 24 by 36. And you guys don't have to do this, but I'm just showing you guys as a demonstration, more or less. Oh wait, you gotta do not box, you have to do rectangle. You can also do 3D in here. I would not recommend it whatsoever. Nobody uses it. Do not do it. Just a word of advice if you guys end up installing CAD. So, and a completely unrelated side note. So, okay, so this is an issue that I've found happening a lot. The reason why it happens is because sometimes programs don't like each other. And sometimes, like, how we were talking in the last exercise, how in RHINO you have to change everything to millimeters. It's kind of similar to that, except for it sucks, like switching back and forth from inches to millimeters to feet over and over and over again. So this is the easier way to do it. So we exported, right, our file as a DWG and brought it into AutoCAD. Now, sometimes what will happen is this thing will be insanely tinier compared to a 24 by 36. So let's just say that this was the template, right, that they have at the cutters. That's 24 by 36. I know it's not, but let's just say in this scenario it is. One of the things you can do, instead of using the scale command, you can use this command called align, right? And what align does is it basically chooses reference points on various objects, and then it will scale the thing to that object. So essentially, if you read here, it says specify first source point. We want our source point to be here, which is the left-hand corner of our template. Then it's going to ask us for the first destination point. We want it to be the first corner on this box, right? And then you do the same exact thing. So we want the second source point to be the second corner on the right, and then we want the reference or destination point to be that. Then it also asks you for a third. You don't need to do a third because we're only just going to use those 2 reference points. So essentially what it's saying is the width here corresponds to the width of that object there, and then it'll scale to it. So you'll click enter, it'll say scale objects based on alignment. We'll click yes, and there you go. Now you have your 24 by 36 template scaled up to the correct size. So and that's if it comes in too small. So that's just something I like to do instead of having to go into RHINO and change settings around all the time. So if you would prefer not to do that, because I know learning a couple commands from various programs is a little hard sometimes, what you can do instead is we can just go back to RHINO and we can just switch our unit settings from inches to feet, because that's what it'll recognize when typically importing in feet. If you have any more questions about just the overall process of laser cutting and how some stuff like that works, we can go back to the Digital Fabrication Lab website, the process, and then it goes over a little bit more stuff, right? So like the policy, there's setup. So basically it shows, gives you kind of examples, stuff like that, how to schedule appointments, the standard sizes, max bed size is 36 by 48, but not a lot of people use that one. Then let's see, approved material. This list you can also find physically at the Fab Lab as well, but they have this in here. What else? Oh yeah, the template file. I probably could have just downloaded that. That would have been a lot easier, wouldn't it? I forgot they even let you download that. So we'll do that real quick because that might be a little bit easier to actually show you guys using the actual template file they got. Okay, whatever. So we'll open this up. There you go. So it looks a little bit different nowadays, but it's essentially the same thing. They don't have these steps here, but same exact deal, right? See how it's laser score, laser cut. So the reason why we did it in RHINO is we don't have to do all that crap here now, essentially. So making it easier in programs that you guys already know how to use, essentially. So let's see, let's highlight this. We'll copy it, Control C, right? Control V to copy in. Whoa, that's way too big. So here's a great example. This needs to be scaled down to that size. So why not just use the same exact command we learned previously, right? So we'll highlight this, do the same exact thing. We'll just do align. First point here. Second point is going to be here. Then we'll do the second point here. And the next one is going to be there. Then we'll click enter and scale. And there we go. That's it. So another thing, right, is the border, right? You don't want the laser cutter to try to cut out the border. So make sure you delete that as well. So literally you can just type in delete or just click the delete button. So because you don't want it to cut the overall border of the material, you only want it to cut, you know, your walls and things like that themselves. So you delete this, and then assuming that my material was whatever example size I gave, delete that as well, because we don't want to cut around that. So now we know that that material at that specific scale will fit on the laser cutter and cut the material that I want it to cut. So then you could save it if you wanted to as well, and then just bring that file in. So a couple things you could do is you could either email the file to yourself, log in on the computers that they have there plugged into each laser cutter, and then download the file, you know, from your email onto that computer, or you could just bring in a flash drive, right? However you get that DWG onto the computers they got set up per laser cutter out there is up to you, essentially. But yeah. Yeah, I think that's everything. I think that's everything. Okay, any questions at all? None whatsoever? Awesome. I expect you guys to get it right on the first try then. Cool. Okay, so next up what we could probably do